Yeah, then we come to this question. It says, consider the equilibrium below. So this is the equilibrium. And A says, state the enthalpy change for the reverse reaction. Okay, you have to take note that for the forward reaction which you are having here, enthalpy change is less than 0. The enthalpy change for the reverse is going to be the opposite of this one. What is that? Greater than 0. So the answer is going to be enthalpy change greater than 0. Yeah. Then we come to this question. It says, temperature was increased on the system above. And the question says, state what happens to concentration of this: sulfur dioxide, oxygen, sulfur trioxide. And how do you go about that? Okay, let's use this space. Okay, you have to know that this is our equilibrium. It is 2SO2 plus oxygen giving you sulfur trioxide, and enthalpy change is less than 0. Now I need you to know that this so-called enthalpy change or heat of reaction is always for the forward. So, in other words, forward reaction is exothermic. Less than 0 means exothermic. So it's exothermic. And what does that mean? That the reverse is endothermic. Okay. Then with that comes Le Chatelier. What does he say? He says that whatever you do to the equilibrium is opposed. Okay? If you increase temperature, the equilibrium shifts in the direction which absorbs heat. And if you reduce temperature, the equilibrium shifts in the direction which produces heat. Now, we've just realized that we are increasing temperature. So increasing temperature favors the direction which absorbs heat, and that direction is endothermic. So what are we going to do here? You look for endothermic reaction, and this is it. And this direction is favored by increase in temperature, according to Le Chatelier. I need also to remind you that exothermic is favored by decrease in temperature. Because when you decrease temperature, the equilibrium will shift in the direction which releases it. And the direction which releases heat is exo. Exo releases heat, while endo absorbs heat. Okay, back to the question. We're increasing temperature, and which direction is favored? Endothermic. Why? Because it absorbs heat. Okay, then what do we see? Endothermic is reverse. So reverse means what? That whatever this reaction, this is the direction which is going to be favored. So reverse implies that this one is going to decompose to give you this and to give you this. And these are the answers. So let's come to answering. So what do we say? Sulfur dioxide. The answer is increase. Oxygen, what is it? Increase. Sulfur trioxide, what is it? Decrease. Yeah. Then comes this question. It says, state what happens to. We have to remember that we are dealing with increase in temperature. Temperature was increased on the system. Okay? And the question says, state what happens to the position of equilibrium. Okay, to assess this, what do we do? The best way is to rewrite the equilibrium. It is 2 sulfur dioxide plus oxygen, giving you sulfur trioxide. Enthalpy change is less than 0. This is what we are going to deal with. Okay, you need to know that where do we look to assess effect of temperature? We look at that, the enthalpy change. And I need to remind you again that whatever you have here is for the forward. So this reaction forward is exothermic. Okay, what does that? That this implies that reverse is endothermic. And we need to go to Le Chatelier. What does he say? He says that increase in temperature favors the change which decreases temperature or which absorbs heat. And that change is endothermic. So this one is the one which is favored. So this is favored by increase in temperature. And what do we notice? It's reverse. So which means that for increase in temperature, the direction which is going to be favored is reverse. But you need to know that for the position, it is this. What is it? Reverse is favored. Yeah, that is it. Reverse reaction is favored. So we come to enthalpy change. Okay? Yes. When you increase temperature, what happens to enthalpy change? It remains unchanged. Enthalpy change is entirely dependent on the nature of the reactants and products. So as long as you have sulfur dioxide reacting with oxygen to give you sulfur trioxide, and enthalpy change is the same. Yeah, that is it. Remains unchanged. Yeah. Then we come to this one, equilibrium constant. What happens to equilibrium constant when temperature is increased? Here you need to know that when you look at the two kinds of reaction, one endothermic and two exothermic, you have to know that for endothermic, increase in temperature increases Kc value, and decrease in temperature decreases Kc value. Okay. Then you go to exothermic. For exothermic, increase in temperature decreases Kc value, and decrease in temperature increases Kc value. This is very important for you. It's very easy to understand without cramming. Endothermic follows the temperature. Kc follows the temperature. You increase temperature, you increase Kc. You decrease temperature, you decrease Kc. For exothermic, it goes in opposite direction. You increase temperature, Kc decreases. You decrease temperature, Kc increases. So back to the question, the equilibrium constant. Temperature increased, and we know that the reaction is what? Is exothermic. So we go to this side, and what do we say? Increase in temperature decreases Kc. So this is it. So let's put it down. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we urge you to subscribe, to comment, to like, to share. And we need also to remind you that Physical Sciences Silver Bullet is a YouTube science channel handling physical sciences grade 12, 11, and 10 perfectly well. We believe we are unrivaled. And grade 8 and 9 natural sciences. Those people who are using our channel, we are advising you that when you go to the channel, don't go to videos because of the wide scope of this channel. Go to playlist and select the material of your level. We believe you will not regret it. Stay well. We love you. Bye-bye.